Hello and welcome students. This is second lecture on mathematical logic. In first lecture, we have done what is a mathematical statement. We have covered a mathematical statement. So for mathematical statement, what we had done was a sentence which is a declarative sentence, declarative or assertive sentence which has a truth value, true or false, which has a truth value, true or false, is known as a mathematical statement. What is truth value of a mathematical statement? This also we have done. Truth value of a mathematical statement. If the mathematical statement is true, then we call it the truth value of the mathematical statement is T or true. If a mathematical statement is false, then we say that its truth value is false, that is F. So there are two truth values of a mathematical statement. Remember students, a mathematical statement is always declarative or assertive. And we had also done the exercise on that. If you want some more problems, you can solve from respective textbook. From your textbook, you can solve some more problems. The idea has been covered. This is lecture number 2. In this lecture, students, we are going to deal with logical connectives. Today, we are going to start with logical connectives. So I will teach you what are logical connectives. For logical connectives, first we need to understand that these are nothing but words or phrases. They are words or phrases. What is meaning of a phrase? A phrase is group of words. So when I have a single word, so I'm now writing what is logical connectives. So if I have a word, a single word or a phrase. What is a phrase, students? Phrase means group of words. So a single word or group of words which is used to connect two statements are called logical connectives. Word or phrase used to connect two statements is called a logical connective. If you go simply by the words, you will understand. See, this logical, this comes from the topic mathematical logic. So something which is pertaining to the idea of logic, mathematical logic, logical, and then connective, something which is going to connect, connective. So what is a logical connective? The one which is going to connect, it is going to connect, join, it is going to join. So a word or a phrase, a word or a phrase, a word or a phrase used to connect two statements is called a logical connective. Now, what are different types of logical connectives that we have to see? We are going to see the following logical connectives here. We have logical connectives like and, or, if, then, if and only if, not. So how many logical connectives we have, students, here? And it's a single word, or it's a single word. These are connectives. Where am I going to use this and or these words? Where will I use? I will use it to connect two statements. As we go ahead in the topic, you will understand more about it. I'm going to use and to connect two statements. Or, now look at this. This is what? This is group of words. This is if then. I'm going to use this group of words to connect two simple statements. Now, what are simple statements that you will understand in time to come? See, this is group of words. If and only if. This is group of words. It's a phrase. So I'm going to use this to connect two statements. Now here, when it comes to not, try to understand, students. Not is, it's a unary connective. These all are binary. These all are binary connectives. What is meaning of binary connectives? These all are binary connectives because when you are using and, so you will have one statement here, then you will have and then you have another statement here. In between you have and. So there are two simple statements which you are connecting with the help of and. You have two simple statements which you are connecting with the help of and. So since there are two, I call and as a binary connective. It is known as a binary connective. B-I-N-A-R-Y. Binary. Bi for two. You all understand bi. Bi means two because it is connecting two. Same is the case with or. Or is also a binary connective. These all are binary connective, but not is a unary connective. Unary. It's a unary connective. U-N-A-R-Y. Unary. Why? Because not is used for one statement only. It is not used for two statements. It is used for one statement only. That you will understand in time to come. Okay, so okay, students, now see here. In the previous slide, I taught you about the logical connectives. I spoke about logical connectives. What are logical connectives? A logical connective is a word or it is a group of words, that is phrase. And what does it do, students? It connects two simple statements. So with the help of these examples, I'm going to teach you what is a simple statement or a atomic statement. A simple statement or a component statement or an atomic statement. So if you see, students, here the first one is sun rises in the east and Himalaya is the tallest mountain. So you have the logical connective here, and the logical connective is and here what is this word and doing? It is connecting two statements. The first one is sun rises in the east, and the second is Himalaya is the tallest mountain. So these two statements are known as simple statements or component statements or atomic statements. These are those statements which cannot be further, they cannot be further divided. They are atomic statements. And if I join these two, if I connect them with the help of word and, what I get is the compound statement. So what is a compound statement here? This whole thing will become a compound statement. What is a compound statement, students? Sun rises in the east and Himalaya is the tallest mountain. This whole thing is a compound statement. And what about simply sun rises in the east? It is known as a component statement or a simple statement, or it is also known as substatement. You can also call it as substatement. So I can use a different color to say this. This is component statement, or you can call it as a substatement, or it is a simple statement, or it is an atomic statement. It cannot be further divided. Now, if I ask you, sun rises in the east and Himalaya is the tallest mountain. In this, how many statements you have? So you can simply say there are two statements. These are two simple statements which I'm joining using and. So in totality, this become a compound statement. But if I ask you, sun rises in the east, this statement divided further, it is not possible. You cannot break this statement into two or more. That is not possible. But you understand that this whole statement can be broken into two simple statements. Now, same way, students, here, check this. I have a statement, a simple statement. I win a lottery. I win a lottery. I will buy a car. And now what I'm doing is these two simple statements, I'm using a logical connective if then. And using this, I make a compound statement. And the compound statement which I make is, if I win a lottery, then I will buy a car. This is the compound statement. Then I have here the third one. The third is, the simple statement is, you will top the board examinations. You study for 6 hours daily. Now, if I combine these two subatomic statements, substatements or atomic statements, using a connective if and only if, then the compound statement which I end up with is, the compound statement is this. This is compound statement. This whole thing is compound statement. Now, here I have the compound statement as this. Earth is a planet, or Ganga is a river. Ganga is a river. So Earth is a planet. It is a simple statement. It's a simple statement. Ganga is river. it is a simple statement or component statement. But when I join these two together, it becomes a compound statement. Now remember students that these all compound statements that you have, I hope you all have understood what is simple statement or component statement or atomic statement or substatement. And when you join these two with the help of connectives, it becomes a compound statement. Now remember students, every time you are using a logical connective and you get a compound statement, there is a specific name for it. There is a specific name for the compound statements. So the next I will teach you, I will give you a table where I will give you the name of compound statements. So students, as I told you in the previous slide that what are compound statements and component statements, and I told you that each compound statement has got its unique name. So now with the help of this table, I'm going to teach you that when you are using these logical connectives like and, or, not, if, then, if and only if. So when you are using these logical connectives, for each one of these logical connectives, you have a specific symbol. So when you are using and, when you're using the logical connective and, for and you will use this symbol. This symbol, it is conjunction. When you use this logical connective, you use this symbol, and the resulting compound statement that you get, you will call it as a conjunction. What does it mean? It means that here this particular logical connective you have used, this particular logical connective and which you have used, and you form a compound statement. This compound statement is a conjunction. What is this whole compound statement known as? It is known as conjunction. The next one, if I'm using a logical connective or, I will use this symbol. It is this symbol. It looks like V in English alphabet. And when I use this logical connective, I get a compound statement. That compound statement will be named as disjunction. The earlier one was conjunction, and this is disjunction. When I use a logical connective not, the symbol for not is this, and the compound statement which I get in after using the not logical connective, I will call it as negation. If I'm using a logical connective if, then symbol is this, an arrow. You could also make like this, but I will tell you not to go for this because this will unnecessarily take more time. We can have a single line. The way I have made it, you can make such an arrow. So when I'm using the logical connective if, then I'm using this symbol, and the compound statement which I'll be getting is known as conditional or implication. What does that mean? Very simple, students. Very simple. Here I have it. If, then. Check this out. This statement which you have, this compound statement, it is known as implication or conditional statement. This whole thing, try to understand, this whole thing is an implication statement. or it is a conditional statement. The compound statement has a name, implication, or conditional statement. Why? Because you're using if then. Now here, look at this compound statement. This compound statement has a name. It is a disjunction. It is a disjunction. Why? Because you have or in between. And the earlier one was conjunction. I have not written the example of not, but if you want, you can write it. Suppose I have a statement here. If I have a statement here, sun is not a star. So what do you notice? You are using the word not to negate a statement. So if I want to teach you more on this, I could say, suppose you had a statement earlier. You had a statement earlier, sun is a star. Sun is a star. So sun is a star is a given statement, and what you do is you negate it. You negate it. You deny the claim sun is a star. You negate it. You say sun is not a star. You say sun is not a star. Remember, students, you are using one single word, not. Now, this thing here which we have, it is known as negation. This statement is a negation. This is not a negation. Why? Because there is no not. You don't have the word not here. So you will make this table. Okay, students, here there is one point that we need to remember, that component statements or sub-statements are denoted by small letters like P, Q, R. They are denoted by small letters P, Q, R. So what does that mean? It means sun rises in the east. This sub-statement you could write as P. You can write the whole thing, you assign it as P. And this you will write it as Q. So symbolically, you all understand that if this sub-statement, sun rises in the east, becomes P, and Himalaya is the tallest mountain, it becomes Q. And as you know that the symbolic representation of and is this, then the whole compound statement, that is this conjunction, can simply be written as P and Q. P and Q. It is read as P and Q. Same way here, you can check. Here you have, if I write this thing as P and this thing I write as Q, this sub-statement I write it as Q, and you know that OR is symbolically represented by this symbol, so it will become P or Q, read as P or Q. Here you call this as conjunction of P, Q. Here you call it as disjunction of P, Q. So now I'm going to teach you these each compound statements in detail. I will teach you one by one all these compound statements in detail. So let us begin with conjunction. So the first one is conjunction. If P and Q are any two statements connected by the word and, If P and Q are any two words connected by the word and, then the resulting compound statement is called the conjunction of P and Q. It is called the conjunction of P and Q. If P and Q are any two statements connected by the word and, then the resulting compound statement is called conjunction of P and Q. It is written as P and Q or P and Q. You can write it either ways. Remember, students, you can write it this way or you can write it this way. We will prefer to write it this way. This is symbolic representation. What is this? This is symbolic representation. Okay, please. Okay, students, let's have an example here on conjunction. I have two atomic statements. I have two atomic statements here. Root 2 is a rational number, and I represent this atomic statement by the small letter p. As it is said, as I told you in the earlier slide, that every atomic statement can be represented by small letters P, Q, R, S, T, like that. So P is root 2 is a rational number. Then I have another statement, atomic statement or substatement. 4 plus 3i is a complex number. Now what I need to do is I want to write the conjunction of these two atomic statements. So what will be the conjunction of these two atomic statements? The conjunction will be the conjunction of these two. Conjunction of above two statements. Root 2 is a rational number. Root 2 is a rational number, and 4 plus 3i is a complex number. Now you can check here, students, that I'm using the word and that is why I'm writing here that it is conjunction of these two statements. I repeat again, I'm using the word and here. I'm using the word and here between these two, and that is why I'm calling it as conjunction of above two statements. Instead of and, if I could use another connective, then it will never be conjunction. It will be some other compound statement. Further, symbolically, how can I write this? Symbolically, symbolical representation. symbolical representation will be P and Q. You can understand P and Q. Okay, students, now we are going to see the truth value of conjunction, truth value of disjunction, and truth value of various compound statements. So before I take you there, I would like to teach you I'd like to make you understand the concept of truth value of a compound statement. Now you all understand, students, that when it comes to a compound statement will have two or more than two atomic statements. And in between them, you have either a conjunction, or you will have a disjunction, or you will have if then, if this, then this. So you will have different types of compound statements. Now remember, students, if I'm writing here a simple compound statement for you, just check. I'm writing here, sun is a star. I write a statement here, sun is a star and earth is a planet. Now you all understand here that using this and the connective, I'm making the compound statement using these two atomic statements. So let me have this as P, sun is a star. And let me have this as Q, where I write earth is a planet. Now students, if individually I would like to ask you, what is the truth value of P? So you will say P is true. P is true. P is true. Its truth value is T. Then if I ask you, what is the truth value of Q? What is the truth value of the statement Q? Earth is a planet. So you will say Q is true. Q is also true. So remember, students, the truth value of this is true. The truth value of this is true. I'm interested in the truth value of the compound statement. So here, now my question is, what is the truth value of this statement as a whole? What is truth value of this statement? Which statement? This statement, compound statement. So we all need to understand that the truth value of a compound statement depends on the truth value of its component statements and the logical connective. I repeat again, truth value of a compound statement depends on truth value of the component statements and the logical connective used. Here what I see this is true, this is also true, in between I have and. So the compound statement, sun is a star and earth is a planet, is also true. This is true. It is true. Okay, so I would like to write here, I want to write a comment here, that is point to be remembered. Point to be remembered. the truth value of a compound statement, the truth value of a compound statement depends on the truth value of its component statements and it depends on the truth value of its component statement and the logical connective used Students, as I taught you the conjunction statement, so a conjunction statement you saw, it will be like I have one atomic statement P, then the another one I have Q, and in between I have AND, so P and Q. So this becomes a compound statement. This is a compound statement. What I further notice is these two atomic statements, each one of them can have the truth value true or false. Even Q can be true or false. So now I understand that there will be different possibilities. There will be different possibilities of combination of the truth value of these two statements. What does that mean? It means that I can have P as true, and I can have P as true and Q as true. So I will have P true, Q true. I can have P true and Q false. I can have P false and Q true. I can have P false and Q also false. Is it confusing? No. This is very simple. See, I can have P true, Q also true. I can have P true and this is false. I can have P false true. This is P false and Q also false. So I have total 4 different possibilities. So what I understand is, if I want to know what will be the truth value of compound statement P and Q when both are true, what will be the truth value of P and Q when P is true, Q is false, what will be the truth value of P and Q when P is false and Q is true, and when both are false. Now, so many different possibilities I have here. So here we will have to now introduce truth table. We will now make truth table. Why truth table? How does truth table help us? Truth table gives us the truth value of a compound statement for different possible combination of the truth values of its component statement. So what is significance of a truth table? A truth table gives the truth value of a compound statement for different possible combinations of truth values of its component statements. So students, now we are going to check here. We are going to learn the truth table for conjunction statement, a compound statement which is conjunction. So let me have two component statements as P and Q, and the conjunction of these two will be P and Q, like this. So as I told you students that we will have different possible combination of truth values of these two compound statements. So P can be true, and when P is true, P can be true, and when P is true, Q is true. If P is true, say Q is false. If P is false, this is say true, and false, false. So total there are four possible combinations. You can be sure that you do not have more than four possible combinations. There are these four possible combinations. The students take a simple cue by they take a simple method idea for remembering this. They read it this way: T T F F T F T F. So you can also have the same idea. What you will do, how to remember this? Very simple. You will write T T F F, write two T's and two F under P. You can check two T's and two F, T T F F, and then for Q you write T F T F, right? One T, one F, one T, one F. Now this will make you assured that you do not have any more combination left. Okay, so always follow this: T T F F T F T F. Now here we will go ahead, students. Remember that in conjunction statement, when the two component statements are true, then the compound statement, which is the conjunction statement, will also have the truth value true. So when the truth value of two component statements are true, the truth value of the compound statement is true. In all other cases, it is false. Remember students, it is false. So how do I remember the truth table? The idea for remembering the truth table is very simple. In conjunction, remember students, in a conjunction compound statement, when the truth value of both compound statements, both component statements, I'm sorry, I beg your pardon, it is not compound, the both component statements are true, then the truth value of compound statement is true. I repeat again, when the truth value of both component statements are true, then the truth value of compound statement is true. In all other cases, it is false. In short, you can say when P is true, Q is true, both are true, then P and Q is true. In all other cases, it is false. Okay, so here I can write the law here, the law which you all have to remember. See, what's the law? The law is the truth value of P and Q is true. The truth value of P and Q is true when the truth value of its component statements, when the truth value of its component statements P is true and Q is true. The truth value of P and Q is true when the truth value of its component statement P is true and Q is true. In all other cases, in all other cases, the truth value of P and Q is false. Okay, you can remember it this way, you can remember the law this way, or you can remember it this way. You can say, when P is true and Q is true, then P and Q is true. Then P and Q is true. In all other cases, P and Q is false. And you have to learn this law, my dear students, because if you know the law, you will be knowing the truth table very easily. Those all students who do not remember the law, they struggle. I would like to say here, there is one more point which we all must remember. Students, there are certain words which can be used in place of and. I repeat it again. There are certain words like but, yet, though, still, moreover. These words can be used to join two component statements in place of and. Like suppose if I say, I want to go to Kolkata. I want to go to Kolkata, one statement, and the trains are not running. So I used and here. I want to go to Kolkata, and trains are not running. So now you understand that the component statements are this and this. I can remove this and I can write it here but. So remember, I write here, I want to go to Kolkata, but trains are not running. So what is this but doing here? But is once again playing its part, which is in place of and. But is a substitute here in place of and. So but is same as and. But is same as and here. Okay. Similarly, we will get the examples where we will have yet, though, still, moreover. Okay. So you can copy this also. So students, what we have completed so far is the compound statement conjunction. We defined what is conjunction of two statements. Then we took an example for conjunction of two statements. Now let's do the disjunction. The next one is disjunction. So let me remove this, and here itself I write disjunction. Okay. So disjunction. So what will be the symbolic representations for disjunction? You write this, which looks like the English alphabet V. So here the definition is, if P and Q are any two statements connected by the word or, this time it is or, then the resulting compound statement is called disjunction. What is it called, students? It is called as disjunction of P and Q. It is written as P or Q. It is written as P or Q, or you know it, it is written as this. You know it, it is written as this. Okay, so this becomes the definition of disjunction. Now let's have an example. Okay, I repeat once again here for you. See, disjunction of two statements. If P and Q are any two statements connected by the word or, remember you are using the logical connective or, then the resulting compound statement is called disjunction of P and Q. It is written as P or Q or P disjunction Q. This is symbolic representation. Now here the example, let P be root 2 is a rational number Q, 4 plus 3i is a complex number. So the disjunction of above two statements, not the conjunction. What we are writing, students? We are writing disjunction of above two statements. Disjunction of above two statements will be root 2 is a rational number, or what you will write here, my dear students? You will write here or. Or 4 plus 3i is a complex number. This will be the disjunction of these two. And symbolic representation, how will it be, students? It will be P or Q. Okay, you will all copy this. So students, we will now we will study the truth table for disjunction as we had done the truth table for conjunction. As we had done this, now we are going for truth table for disjunction of two statements, that is for sure. So here I have the two statements. The component statements are PQ, and the disjunction of these two statements will be P or Q. P or Q. Now, as you know, students, there will be different possible combinations. There will be total 4 different possible combinations. T, T, F, F. I write in the first column, that is under P, and here I write T, F, T, F. Now, what will be the truth value of P or Q? When P is true, Q is true, P or Q will be, remember, it will be true. What will it be? It will be true. Here it will be true. When P is true, Q is false, then also it is true. I will write it, don't worry. When P is false and Q is true, then also it is true. So here what I followed that this is true, this is true, this is true. And when both are false, then it is false. Remember, students, both are false, then it is false. In all other cases, it is true. So remember, students, that truth value of a disjunction statement, the truth value of disjunction compound statement is false when both the component statements have truth value false. If these two are both are false, then it is false, otherwise it is true. And this is the law. You have to remember this, as I said. Okay, in conjunction, what it was, my dear students? What was in conjunction? When both were true, then it is true. When both true, then P and Q is true. In other cases, it is false. And in disjunction, what it is? When both are false, then it is false. Otherwise, it is true. In disjunction, if you have, even if one is true, it has to be true. Even if one is true, even if a single statement is true, it is true. So see here, I give an example. Suppose I have true or false. It is true. If I have false or true, then also it is true. If I have true or true, then also it is true. Remember, even if one is true, true, one is true, both are true, still true. Yes, but false or false, both are false, then it is false. So remember, even if the single is true, it will be true. Okay, this you have to remember. So now what I do is I write the law. So here I write law, the law which you have to remember. How do you remember the table? You remember the table only by knowing the law. So I write here the truth value of a disjunction statement disjunction P or Q is false when the truth value of its component statements P is false and Q is false. In all other cases, the truth value of P or Q is true. The truth value of P or Q is true. This is one way you can remember the law, or the other way is you can say here, when P and Q both are false, then when P and Q both are false, then P disjunction Q is false. Otherwise, P disjunction Q is true. You can copy this. So students, let's solve few examples. Here I have a question. There is a question which I write here. The question goes as example 1. It goes as, express the following statements in symbolic form. Express the following statements in symbolic form. Okay, so the first one is E is a vowel. E is a vowel. Or 2 plus 3 equals to 5. Now you can check, students. This is a compound statement and it is a disjunction. Why? Because there are two simple statements and they are connected by a logical connective OR. So when you are using OR, it becomes disjunction. Now how do I solve this problem? See, I tell you. The answer of this will be as follows. I will write let P. I write P as the first one. E is a vowel. And I write Q as the second one, which is 2 plus 3 equals to 5. 2 plus 3 is 5. Now what I do is I write the symbolic representation of this. Express the following statement in the symbolic form. So now I write final answer. I write symbolic form. Symbolic form. What it will be? It will be P. This whole thing is P. This is R, which has symbol this, and this is Q. Over. That's it. This is your answer, my dear students. This is your answer. Yes. Next, the second one is mango is a fruit, but potato is a vegetable. So the second one is mango is a fruit. Okay, the second question is mango is a fruit. Mango is a fruit, but potato is a vegetable. It's a vegetable. So now what you do here, you understand, students, this but is actually a substitute for and. We are using but here for and. So what we will do once again, see, we will assume, we will begin the answer as, how the answer will be? The answer will be, we will write let, and you know this one is my P. This one I will write it as P, okay, and this one will be Q, which I'll have to actually write. Remember that you need to write. So you will write P and you will write here mango is a fruit. You will write Q, you will write potato is a vegetable. Please don't write but. Don't write but anywhere, because but is only the logical connective. As I don't write or anywhere. No, or is a connective. So this is P, this is Q. Same way here P, this is Q. And now the symbolic form. What will be symbolic form, my dear students? It will be P and Q. See, this but is for conjunction. Okay, so this you will do. Now the third one. The third one is, the third question here given is, milk is white or grass is green. Milk is white. Milk is white or grass is green. Now, once again, students, you understand here it's or, so it is actually a disjunction. So I will take this as P and this as Q. This will be, once again, a homework problem. This is homework, students. Okay, you will solve this on your own. Then the fourth one is, I like playing but not singing. Once again, I like playing but not singing. I like playing. I like playing but not singing. So remember, students, but this particular word here is used as a substitute word for and. So I like playing, this will be P, and not singing, I like playing will be P, and not singing, that is I do not like singing. I do not like singing. Okay, this will be Q, but don't write Q as not singing, please. This much English knowledge we all should have. So here I go ahead. See, I write the answer for this. I write the answer for this. So what will it be? I will write let P equal to I like playing. I like playing. The same person is saying I like playing, but I do not like singing. So in the next one, he is not saying I do not like singing. He is simply saying, that's the way we say, you know, if I have to say that I like playing, I do not like singing, I like watching movies, but I do not like watching plays, dramas. So every time, you know, I will not say I will not repeat I, but it is to be understood that I is there. So I like playing, and Q is I do not like singing. I do not like singing. So here it will be, the symbolic representation will be symbolic representation, or you can say symbolic form rather. Symbolic form will be, it is P and Q. P and Q. Okay, students, look at this fifth question. The fifth question is, it is not using the word and. The logical connective and is replaced by still. It is replaced by still. So see, what does this compound statement say? This compound statement says, even though it is cloudy, excuse me for my handwriting, even though it is cloudy, it is still raining. Okay, so here, what are the simple atomic statements? See, it is cloudy and it is raining. It is raining. That still you have to remove. So I will take P as, see what is P here, I will write. So this is, okay, so here I will go for, I write here P. Let P be, it is cloudy, and Q is, it is raining. It is raining. So what it will be? It will be the symbolic form. Symbolic form is P and Q.